Something else. I want to try and solve this system right here. And again, I want to show you how to do it in Matlab. We'll do some more by hand, but I want to show you how to do this one in Matlab, just in case you get a larger one and you need to be fast. So this is our system. You notice that it's a homogeneous system, and we get an initial condition too, so don't forget that. So let's go to Matlab, and let's input this. This is, first of all, let's clear all other outputs. I'm gonna put that this is exercise 13, and we'll go from here. So the first thing I wanna do, I wanna clear all previous variables. And you do that with the command clear all. That is because you have all these variables. I might use some of the same names, and if I do, I want MATLAB to start with a new variable and not with a value that we got from some other exercise. So we put clear all here, and then I'm going to define the coefficient matrix. So what was the coefficient matrix? So first of all, to define a matrix, you have A and you set it equal, and then you open the square brackets. Had it been just a number, like if I wanted to give it a value, I'd put 1 and that'd be it. Since I want to give it an arranged amount of values, which is a matrix, then I want to use the brackets. I'll type all of the first row, and then the semicolon tells MATLAB that you ended that first row and you're starting the next row. So this is the second row, and that was a 2 by 2. So that's all we need now. And now what we want to do is we want to check the eigenvalue type, because we can have distinct real eigenvalues, we can have repeated eigenvalues, or we could have complex. And so we use this function to find the eigenvalues, and then I put control enter. We find two distinct eigenvalues. Okay, so that tells us that we can use the Jordan, and I'm going to use the Jordan to find the eigenvectors and values of the matrix. Now, just keep in mind that probably a 2 by 2 you want to do by hand. So maybe next time I have a 2 by 2, or I'll make another video. I'll call this part A, and then we'll do it again, but we'll do it again by hand so you see both ways. So Jordan here of A, that'll give us vectors and values. I always forget though that the Jordan outputs two things. It outputs the vectors first and then the values. So we want to assign it something where the function can give to each an answer. So I do that, control enter, and the first thing are going to be the vectors, the second things are going to be the values. So with this, I can already write what the solution is going to be. So writing the general solution, that's because each of these is going to be a solution. So let's define the single solutions first, writing the single solutions. So one solution to this problem, I'll call it x1, is going to be what? It's going to be this vector. This is an eigenvector 1, 1. This vector does not get knocked off its span by the matrix A, by the transformation A, multiplied by e to the negative 0.5 or negative 1/2 times t. And then keep in mind that the reason why we're solving the eigenvalue problem is buried in one of the earlier videos in this place where I showed you, I think it was exercise 3, why we're doing it this way and why the eigenvalue ends up being in the exponent here. And then for the second solution, we have 0 in the first row, 1 in the second row, and we multiply by e to the other eigenvalue is negative 1/2 times t, which means I made a mistake at the top. This is positive 1/2 times t. I put a semicolon on both of these because I don't want them to output. And now I'm going to define the general solution. And the general solution is going to be the sum of the two, but it's going to be a linear combination. So it's going to be a constant times x1 plus a constant times x2. Now before I press enter, I realize that we have t's here, and we have c2s, and we have not defined those. So we need to tell Matlab what those are. So defining my variables. And you don't need to put it as a second line. You can put it right before you use them. But I like to put them at the top. So you do it with the command sims, and then you have C1, C2, and T. Now we press Control Enter, and it should execute this command and output this as a solution. Now to verify that this is a solution, verifying my solution, how are we going to do that? Well, to verify the solution, I am just going to put the derivative of my general solution on the left-hand side of an equal sign, and then the matrix times my solution on the right-hand side. I press Control Enter, and I want to see here if I get that the left-hand side is equal to the right, which indeed I do, which makes me confident that this is indeed a solution. And this was the end of part A. I'll show you part B. See you next time.